Hello and welcome back to part 2 of chapter 9. We're still on page 3 in your notes, and right after I stopped the video I realized I had one other thing I needed to say about this particular slide here where you drew the pictures, and I didn't quite get all of my thoughts finished there because I was supposed to tell you about the area of a triangle. And remember, all of these formulas you can find on the yellow sheet that you picked up or hopefully can get a hold of from class. But the area of a triangle formula is right here. It's 1/2 times the base times the height. Okay, 1/2 times the base times the height. And one thing you need to be aware of, that the height, similar to the parallelogram, has to be a 90-degree angle from the base, which would be the one flat side, to the highest point. Okay, so that would be the height right there. If I had this triangle right here, this is a 90-degree angle, so that is the height right there. Or if we had this strange one here, if we would have to actually, that's not right, ignore that. What you actually would have to do is extend the triangle out here and make a 90-degree angle here for the height. Right there. Okay, so it has to be from one side to the highest point, a 90-degree angle to get the height. Okay, and the area of a trapezoid is found by this strange formula right here, where if we mark the parallel sides B for base, and then the height would be a 90-degree angle from one of the bases to the other base right there, and there's the other one on the upside down trapezoid. In order to find the area, and that's slightly cut off there, sorry about that, I'll rewrite it here. The area, it's equal to 1/2 times the height times the sum of the bases. Okay, now again, you don't have to worry about memorizing this because it's all on the yellow sheet. 1/2 times the height times the sum of the bases. Notice that the bases are in parentheses, meaning you have to add those before you multiply times h. And here it is. Here's the yellow sheet. Here's the trapezoid section right here. And then you can see the formula that I just talked about is right here. So you don't have to have it memorized for the test, but you will need to be able to practice with it. And I encourage you to have that sheet with you when you're doing your homework. I think if you do that and you get used to where everything is, it'll be less stressful when the test time comes. So if we were to find the area of this triangle, let's practice one here. And I'm looking at your notes, and it looks like it printed really oddly. That for some reason 2 of the 12s printed. Just scratch one of those off. The height there is supposed to be 12. And again, that's a 90-degree angle right there. So if we just take the formula 1/2 times the base times the height, we plug it in like that. 1/2, you can use 0.5 in your calculator if you want to for 1/2. Multiply everything across. It's 96 centimeters squared. Notice the label when you find area should be the power of 2. Again, because what you find when you're finding the area of something, you're finding the number of squares that fill it up. Now on this particular shape, some of the squares would just be slightly cut off, but that's okay. This mathematically would help us answer that question even after all of the triangles have been sliced just to fit in there, or all of the squares have been sliced to fit in there perfectly. Okay, so that's 96 centimeters squared. Let's take a look at another example here that I believe is in your notes at the bottom of page 4. Your picture is filled in for you if we have that. So the height there is this side over here, okay, which I have labeled as 10. So that's the height. So the base is 5. Now the base is only this length right here, okay, because that's the actual triangle. Okay, so don't be deceived if I were to give you a number here. Okay, don't be thinking that the base is 8 there. It's 5, because the length of the you can't see here because you can kind of see it because my white is over the black, but that is the base length because that is the length of the triangle there. So if you're going to find that value, you would multiply 1/2 times the base times the height. 1/2 times 10 times 5, or 1/2 times 5 times 10. Either way you do it, it comes out to be 25 centimeters squared there for you. So hopefully that makes sense to you. Okay, and that should take care of, I believe, the triangle examples, so get comfortable with that. And then the trapezoid examples, I worked one out for you here. Let's say you have this trapezoid where you have the base lengths are 6 and 10, the height length is 8. All we're going to do is we're going to plug it in this formula that's right off your formula sheet. 1/2 times height times base. All right, the height there was 8. You can see it lined right up here. Just plugged it in. The height was 8. One of the bases was 10. One of the bases was 6. You add 10 and the 6 together. You got 1/2 times 8 times 16. Multiply that through. There you go. 64 inches squared is the area of that trapezoid. And like I keep saying over and over, all you have to do is be able to substitute those values into the formula, and you can use your calculator. If you do that, you should be just fine. Hopefully you're comfortable with that. And that takes us to this strange looking figure. It says find the area, but you'll notice we don't have that particular figure on our formula sheet. So this is called a composite figure. And what you're going to have to do basically is take what you do know, and here's what we know. We know the formulas for area for all of these shapes up here. We've got the rectangle, square, parallelogram, we've got trapezoids, we've got some other two-dimensional shapes down here, or here we go, triangle and circle as well. So you're basically going to have to use what you know to work through this problem. There's a couple ways you could do it. One way would be to slice this into sections like this. I wouldn't recommend this. You could slice it like that. You could figure out these unknown sides, and you could add the area of this plus this plus this, and that's fine. You could also slice it another way. Let me clear that out. You could slice it like this. You could slice that. You could find the area of this. You could slice it like this. You could find the area of that and that. Add them all together, and that's fine. It would get the solution for you. But I think there's an easier way. That's one way to do it. And another way to do it would be to, hold on, he's got a pop-up message that I don't need. There we go, made it go away. Another way to look at this problem would be to consider if you have one giant rectangle like this. If you find the area of that, okay, I'll call that the large area. All right, and then if you subtract the small area, which is basically the missing piece. You see that big chunk that's missing? If we can figure out the area of that missing piece and the area of the large piece, we can solve this problem. So let's try that, because I think that's the easiest way. So let's take a look at this area that I just made white. I also noticed on your notes there's a little floating 2 in the middle of here, and that wasn't actually supposed to print there. It'll come up in just a minute, so you can just ignore the little floating 2 if that's on your paper. What we could do first is figure out that the length of this is 3. And the way that I figured that out is, since that is 6, and that's 2, and this is 11, all I have to do is figure out, well, what else would I need? If I had 6 and 2, what do I need here to get to 11? Well, 6 and 2 is 8, so 11 minus 8 is 3. So that length is 3. So this side here is 8 by 3. 8 by 3 is 24. Okay, that's where the 2 was supposed to come out, by the way. That's why it's on your paper. That's 24 centimeters squared. So if I can find the area of the large, which will be 11 times 12, all I have to do is subtract the 24. Okay, and here I did it. 132, okay, that's the large, minus the small area, which is over here, the 24. Okay, there's your answer right there, 108 centimeters squared. So whether you want to chop that into several rectangles and add them together, or do it this way, if you did the math right, either way should work, as long as you come up with 108 centimeters squared. And either way is fine. But that way, when you're subtracting, it's just a little faster because you only have to deal with 2 numbers. Okay, I'm going to stop this video here. We'll be done with section 9.2. We'll come back and start with circles in a moment.